Hey guys, welcome to the chapter 2 of Thinking Visually. Um, let's get started. Chapter 2, Thinking by Visual. Visual thinking is pervasive. Visual thinking pervades all human activity from the abstract and theoretical to the down to earth and everyday. An astronomer ponders a mysterious cosmic event. A football coach considers a new strategy. A motorist maneuvers his car along an unfamiliar freeway. All are thinking visually. You are in the midst of a dream. You are planning what to wear today. You are making order out of the this array on your desk. You are thinking visually. Surgeons think visually to perform an operation. Chemists construct molecular models. Mathematicians to consider an abstract space-time relationships. Engineers to design circuits, structures and mechanisms. Administrators to organize and schedule work. Architects coordinate function with beauty. Carpenters and mechanics to translate plans into things. Visual thinking then is not the exclusive reserve of artists. As Rudolf Arnhem observes, visual thinking is constantly used by everybody. Directs figures on a chessboard and designs global politics on the geographical map. Two dexterous moving men carrying a piano along a winding staircase think visually in an intricate sequence of lifting, shifting, and turning. An inventive housewife transforms an uninviting living room into a room for living by judiciously placing lamps and rearranging couches and chairs. See, imagine, draw. Visual thinking is carried on by three kinds of visual imagery. The kind that we see, people see images, not things. The kind that we imagine in our mind's eye as when we dream. The kinds, and the third is that the kind that we draw, doodle, sketch, or paint. Although visual thinking can occur primarily in the context of seeing or only in imagination or largely with pencil and paper, expert visual thinkers flexibly utilize all three kinds of imagery. They find that seeing, imagining, and drawing are interactive. Interactive imagery. The interactive nature of seeing, imagining, and drawing is shown in diagram figure dramatically in figure 2.1. Okay, seeing, imagining, drawing. The overlapping circles can be taken. Overlapping circles can be taken to represent a wide variety of interactions where seeing and drawing overlap. Where seeing and drawing overlap, seeing facilitates drawing, while drawing invigorates seeing. Where drawing invigorates seeing, right? Where drawing and imagining overlap. Drawing stimulates and expresses imagining, while imagining provides impetus and material for drawing. Where imagining and seeing overlap, while seeing in turn provides raw material for imagining. The three overlapping circles symbolize the idea that visual thinking is experienced to the fullest when seeing, imagining, and drawing merge into active interplay. The visual thinker utilizes seeing, imagining, and drawing in a fluid and dynamic way, moving from one kind of imagery to another. For example, you might see a problem from several angles and perhaps one choose to solve it in the direct context of seeing. Now, prepared with a visual understanding of the problem, you imagine alternative solutions. Rather than trust to memory, you draw a few quick sketches which you can later evaluate and compare, cycling between perceptual inner and graphic images to continue until the problem is solved. Experience this interplay between perceptual inner and graphic images for yourself as you solve a challenging and somewhat difficult classic puzzle. 2 1. You seeing, imagining and drawing to solve this problem as follows. Simulate the pierced block with a cardboard. Cut off with scissors and cardboard. Seek to see a solution by actual cut and try methods. Close your eyes and seek a solution in your imagination. Make sketches. Seek a graphic. Seek a solution in your imagination. Make sketches. Seek a graphic solution. Consciously alternate between step 1, 2, and 3. An answer to this puzzle is illustrated at the end of this chapter. Okay. So what this thing is, plate the pierce block, the cardboard cut out. Okay, let's move on. Next paragraph. You guys can solve this problem, right? Now, visual thinking is obviously central to the practice of architecture, design, and the visual arts. Less obvious is the importance of visual thinking to other disciplines such as science and technology. In the next few pages, I will present a few brief accounts of seeing, imagining, and drawing in the thinking of scientists and technologists. Interspersed with these, I have placed related problems that will help you to relate these accounts of others to your own experience. Seeing and thinking. Discoveries in the direct context of seeing are common in the history of science. For example, Sir Alexander Fleming noticed while working with some plate cultures of Staphylococcus that one colony of bacteria had apparently become contaminated and died, although most bacteriologists would have overlooked it. Knowing that some bacteria can interfere with the growth of others, Fleming saw it in a way that enabled him to transform a routine laboratory accident into a profound scientific discovery of. Why did Fleming discover penicillin when another scientist saw the same thing and thought it is nonsense? Nonsense. Because habits of seeing and thinking are intimately related. Fleming, like most creative observers, possessed a habit of mind that permitted him to see things afresh from new angles. He was not burdened by that invertebrate tradition according to which thinking takes place remote from potential experience. He did not look and then sit down to think. He used his active eyes and mind together. Experience using your eyes and mind together in puzzle 2 cards and discards. In row of 5 cards shown, figure 2 3, there is only one card correctly printed, there being some mistake in each of the other 4. How quickly can you find the mistake? Let's see if we can find the mistake. So what we are looking is pattern, or see, this one is mistakenly printed because we are looking for this this symbol, but we have this. That's a mistake, right? Now what we gotta do, find, see, this one is also different. This one is correct though. 10 10, this one is, these all are printed kind of like wrong way. Yeah, 10 should be visible like this, right? uh, okay. Watson and his colleagues visualized this complex structure acting the large three-dimensional model. He writes, Okay, yeah. Another form of thinking in the context of seeing is described by Nobel laureates James D. Watson in the double helix, a fascinating account of the discovery of the structure of the DNA molecule. Watson and his colleagues visualized this complex structure by interacting directly with a large three-dimensional model. He writes, quote, only a little encouragement was needed to get the final soldering accomplished in the next couple of hours. The brightly shining metal plates were then immediately used to make a model in which, for the first time, all the DNA components were present. In about an hour, I had arranged the atoms in positions which satisfied both the X-ray data and the laws of stereochemistry. The resulting helix was right-handed with the two chains running in opposite directions. Another 15 minutes fiddling by Francis Crick failed to find anything wrong, though for brief intervals my stomach felt uneasy when I saw him frowning. Although a complex structure such as the DNA molecule is difficult to visualize in the imagination or on paper, one of Watson's colleagues found the model shown in figure 2.24. However, 24 DNA structure. However, as Watson observed, his Nobel Prize-winning success by this method of visual thinking convinced the doubter that our past hooting about model building represents a serious approach to not the easy not the easy resort of slackers who wanted to avoid the hard work necessitated by an honest scientific career. Watson's account in the double helix also gives the reader excellent insight into the competitive excitement of science. Ideally, the next problem, 2-3, an expert and experience in thinking in the direct context of seeing should be approached in the spirit of a competition. 2-3, spaghetti cantilever. With 18 sticks of spaghetti and 24 inches of scotch tape, construct the longest cantilever structure that you can. Here are three additional constraints. First, tape fasten the base of the structure within a 6-inch square horizontal area. Don't make drawings, think directly with the materials, and then design and build the structure in 30 minutes. Measure length of cantilever from the point on the base nearest to the overhang of the cantilever. The relation between saying and thinking will be treated further in section 3, seeing. Imagining and thinking. Inner imagery of the mind's eye has played a central role in the thought processes of many creative individuals. In rare thinkers, this inner imagery is extremely clear. For example, Nikola Tesla in the technological genius, whose list of inventions includes the fluorescent light and the AC generator, could project before his eyes a picture complete in every detail of every part of the machine. These pictures were more vivid than any blueprint. Tesla's inner imagery was so like perceptual imagery that he was able to build his complex inventions without drawings. Further, he claimed to be able to test his devices in his mind's eye by having them run for weeks, after which time he would examine them thoroughly for signs of wear. At will, many after which time he would examine them thoroughly for signs of wear at will. Many important thinkers have obtained imaginative insights more or less spontaneously. For example, the chemist Kekule came upon one of the most important discoveries of organic chemistry, the structure of the benzene ring. In a dream, having pondered the problem for some time, he turned his chair to the fire and fell asleep. Again, quote, again, the atoms were gamboling before my eyes, my mental eye. could not distinguish larger structures, all twinning and twisting in snake-like motion. But look, what was that? One of the snakes had seized hold of its tail, and the form whirled mockingly before, as if by a flash of lightning. I awoke. The spontaneous inner image of the snake beating its own tail suggested to carefully that organic compounds such as benzene not open closed rings. If you identify high intellectual endeavor exclusively with verbal and mathematical symbols, consider the introspections of Tesla, Einstein, and Ketley facial care. To give another example, the following problem 2.4 is best solved by inner imagery. Has your education prepared you for this kind of problems? See, cube. Shut your eyes. Think of a wooden cube, such as a child's block. It's painted. Now imagine that you take two parallel and vertical cuts through the cube, dividing it into equal thirds. Now take two additional vertical cuts 90 degree to the first ones, dividing the cube into equal 9. Finally, take two parallel and horizontal cuts through the cube, dividing it into 27 cubes. Now how many of these small cubes are painted on three sides? On two sides, one side, how many cubes are? Okay, alright, so the cube will be painted on. Cube is like three-dimensional structures, right? So what we have is, let's draw. I think we should draw, or we should imagine. Cube is made of square. I have uh 1 4 5 6 squares, right? So now what it's saying is, now imagine that you take two parallel and vertical cuts to the cube. Well, cubes are symmetrical shape, right? So it doesn't matter how we cut it. Like, let's just cut vertically, right? Imagine cutting vertically. Now we have a something like piece of cake or something, right? So cut it two slices. Now we have well, equidistant. I think it's something like uh, three-dimensional rectangle, if you, right? But uh, a bread, something like a bread, right? Imagine three slices of breads, okay, but with colored on it, right? Painted. Now when we cut it, right? Cut it. The one will be will not be painted. Two will not be painted on their, on one side, and one on the middle will not be painted on two sides. Okay. Now what we are doing is, now now take two additional vertical cuts at 90 degree to the first ones, dividing the cube into equal nines. Okay, 9 cuts. We gotta make 9 cuts on the ones, right? First one. So what we can do is, we have a bread painted on all the sides, but on the, suppose the bread that's on top, and on the very bottom. The upper part of the bread is kind of thick, and the one where there is dot, that pose or something, that's unpainted, right? So now we cut it vertically on nine parts, degree. Now we count the two last part as uh two ones will be two of them will not be painted on that side, because it will be like a rod like structure. But um yeah, and all the other seven of them will not be painted on three sides, right? Okay, so seven, two. And now finally take two parallel and horizontal cuts to the cube. Two parallel and horizontal cuts the cube, dividing it into 27 cubes. Dividing it 7 cubes. Well, the cube is gone, right? Okay, guys, I think, okay, and you know what? This should be an exercise. I think I got the main point from this is that, like, you have to abstract things out, right? Connect different points, like process of thinking. I also related it, you know make thinking easily is that, like, imagine a cube. Technically, suppose instead of thinking of cube, you have a bread, right? A bread cube. Then you cut a slice on it, and then you can imagine a bread colored bread cube. So you can go from there, because we are much familiar with the bread cube, right? It is kind of abstract. Then we thought of rods, like making it easily accessible, and seeing it from different angles. Okay, so yeah, do not be next. Let's move to the next paragraph. Do not be disappointed if you did poorly on this problem. Mental manipulation of inner imagery improves with practice. Experiential exercises for the mind's eye involving many different kinds of inner imagery are presented in section 4. Imagining, right? So, drawing and thinking. Very few people possesses the acuity of mind's eye that enabled Tesla to design and build complex machines without drawing. Most visual most visual thinkers clarify and develop their thinking with sketches. Watson, recollecting the thinking that preceded his discovery of the DNA structure, writes that one important idea came while I was drawing the fused rings of adenine on paper. An example of a chemical diagram drawn by Watson, shown in figure 2.5. Chemical diagram drawn by, as in Watson's experience, drawing and thinking are frequently so simultaneous that the graphic image appears almost an organic extension of mental processes. Thus, Edward Hill likens drawing to a mirror. A drawing acts as the reflection of the visual mind. On its surface, we can probe, test, and develop the workings of our spectacular vision. Drawing not only helps to bring vague inner images into focus, it also provides a record of the advancing thought stream. Further, drawing provides a capability that memory cannot. The most brilliant imager cannot compare a number of images side by side in memory as one can compare a wall of tackled up idea sketches. Two idea sketches from the notebook of John Hubble, the engineer who conceived the lunar landing module, are reproduced reproduced in figure 2.6. Okay. Hubble's draw images show two important attributes of Hubble's drawings show two important attributes of graphic ideation. First, the sketches are relatively rough. Okay. Yep. They are not intended to impress or even to communicate. Instead, they are kind of graphic, talking to oneself. Second, one sketch is an abstract schematic of the voyage from Earth to Moon and back. The other is a relatively more concrete side view of the landing module. Okay. Idea sketching, like thinking itself, moves fluidly from the abstract to the concrete. Drawing to extend one's thinking is frequently confused with drawing to communicate a well-formed idea. Graphic ideation precedes graphic communication. Graphic ideation helps to develop visual ideas worth communicating. Because thinking flows quickly, graphic ideation is usually freehand, impressionistic, and rapid. Because communication to others demands clarity, graphic communication is necessarily more formal, explicit, and time consuming. Education that stresses graphic communication and fails to consider graphic ideation can unwittingly hamper visual thinking. The relation of drawing to productive thinking will be treated section 5 idea sketching. Some problems are most easily solved by graphic means. For example, problem 2.5, with one line with one continuous line that does not retrace itself, draw the pattern shown in figure 2.7. The puzzles used to illustrate various modes of visual thinking in this chapter bear a striking resemblance to visual problems posed in psychological tests of intelligence. In the next chapter, I will briefly review some of these test forms. They will help to shed light on the operations of visual thinking. Okay, I think let's try this one if we can do it. So what it says is, with one continuous line that does not retrace itself, draw the pattern shown in figure this. Okay, we're saying some problems are most easily solved by graphic means. So like graphic means we have to draw. So let's try different iteration. Does not retrace itself. What if I do this? We'll start from here. Here. Okay. Now let's complete this. What we gotta do is let's just draw and see what happens. Okay, what happens? All right. Um. Go the form. Okay. Then we go there, there, and left out this one because we can't think. See. So first is square, and this what we gotta do, line uh, what we can do, suppose this triangle. Now make another. Okay, if we can back like this, reverse no retrace. Okay, so what we have to do is leave one out. Okay, this one. Then gotta do is okay, start this and right this 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 out. How do we do that? Like what's happening here? How the structure is, how it is. Well, from 1.1 to 4. 1, 2, 3. Good point. Well, it's not well. Corners 4 and 2. So what if I make the square first? Somehow I gotta make the square first, right? How can I do that? Well, see that I don't retrace. Okay. It happened. Okay. Yep, I see now. Yep. So that's how you solve the problem. That's really interesting, man. Oh, yep. We solved that problem, right? You just gotta see it. I mean, yeah, like like it says, some problems are most easily solved by graphics. We gotta draw it out, right? Right, and we know repetition, trying it out, seeing how it really works, like extra. So, like before, I was just doing iteration, brute forcing. How would I solve this problem? And then I thought, like points. The points are interesting to me. Like it has 4 points, then it has 3 points. So if I draw it, then my degree of freedom would be here. I should draw 4 lines on these edges, right? On these edges. Then here I have to draw 3 lines. So I from this I interpreted that I don't have to draw it this one first. Most people like I even initially I draw it this one first, and that's what got into me, that stuck us into that one gap. Then I draw the I thought of completing this rectangle first, rectangle or what square first, and then it solve the problem basically, right? So that's how we gotta approach this. Okay, and let's draw it. How did I do that? Okay, let's. Okay, yeah, I did this one, right? And then yeah, I think I gotta see the video, man. It was quite interesting, it just came to me. This one. So it's come back. This one. That's how we do it. Okay, so there are some answers to figure to it. So number of answers to the problem. Can you generate others for what is the minimum volume solution? Solve Rolf Arminus University of California Press is a readable and erudite treatise totally destined classic. If you want to delve deeper into this theory of visual thinking, or if you want to be convinced that visual thinking is the most important kind, I highly recommend by Rodolphe Arhen. Gotta check it out. So these are the references for the book. Arhen, a visual thinking vision. Feldman, art as image and idea. This all Kaufman, G, the book of modern puzzles. Cover. Watson J, the double helix. O'Neill J, prodigal J, life of Garten book. Einstein quoted by J, psychology of invention. Princeton quoted by Webster A, in the act of creating McKim will eat language. You gotta check all of these books out later, and I'll upload these videos reading these materials, reading books on our channel, The Art of Visual Thinking. So that's it, folks. for this chapter, and tomorrow we're gonna be reading chapter 3, images in action. Okay, I'll see you guys in the next video. Thank you.